Okay, pressure law. Pressure law occurs at constant volume. It is generally known as the Gay-Lussac law. Yes, at constant volume we mean isochloric process. Isochloric means constant volume. It states that the pressure of a fixed mass of gas at constant volume is proportional to the absolute temperature of the gas. That is, P is proportional to T. So absolute temperature, take note of that as well. So it means that P over T equal constant and P1 over T1 equal to P2 over T2. So as I've said, it's an absolute temperature, so temperature has to be in Kelvin. If you're giving us degrees Celsius, convert it back to degree Kelvin. So we have a question for us here. It says that a gas at pressure P Newton per meter square and temperature 27 degrees Celsius is heated to 77 degrees Celsius at constant volume. What is the new pressure? You see, volume is constant. That is what? The pressure law. So we have options 0.85 P Newton per meter square, B 0.86 P Newton per meter square, C 1.16 P Newton per meter square, and D 1.18 P Newton per meter square. So the answer is expressed in terms of P. So we're going to try to find our answer in terms of P and see what we have. So from here, we're giving our initial pressure, that is P1, equal to P, and our T1 equal 27 degrees Celsius equal 300 Kelvin, and T2 equal 77 degrees Celsius, which is equal to 350 Kelvin. We add 273. Then our P2 is unknown. So from this statement here from Charles law, P1 over T1 equal to P2 over T2 simply means that our P2 will be equal to P1 T2 over T1. So if that is the case, we are going to have P2 to be equal to also our P1. P1 is P multiplied by T2. T2 is 350 Kelvin divided by T1, 300 Kelvin. When you do this, you're going to have approximately 1.166 P. So if we approximately, you're supposed to have 1.17, but the closest to this answer here we're having is option C, which is 1.16. So it should be an error on their own part, supposed to be to 2 decimal place 1.17 P. So that is that. Then we have another question which says that before starting a journey, the tire pressure of a car was 3 exponential 5 Newton per meter square at 27 degrees Celsius. At the end of the journey, the pressure rose to 4 exponential 5 Newton per meter square. Calculate the temperature of the tire after the journey, assuming the volume is constant. But to assume constant volume, that brings us back to pressure law. So we are to find the final temperature T2. So from this equation, we are given the initial temperature T1 as 27 degrees Celsius, which is equal to 300 Kelvin. And we are given our P1 as this, first pressure 3 exponential 5, our P2 4 exponential 5 Newton per meter square. Therefore, our T2, from this formula, if we do our math properly, our T2 will be equal to T1 P2 all over P1. If we cross multiply and have our value properly, our T1 becomes 300 multiplied by P2, that is this P2, sorry, P2 4 exponential 5 all over P1 3 exponential 5. So this exponential cancel out, 3 here, 1, 3 here, 1. T2 equal to 100 times 4, which is 400 Kelvin. So 400 Kelvin to Celsius will become what? Minus 273 minus 273. 400 minus 273 will give us that's 200 minus 73 as 127 degree Celsius is option D. So that is that. Thank